What was that?
Oh, I asked a really long-winded question about like what the benefits of multi-parent Casper are. And so I guess just to kind of like recap a little bit, my understanding is that with a single parent Casper implementation, we're constantly building a chain of blocks. So like a traditional blockchain. And with multi-parent, you're getting like a true DAG, because now you can, refer back to multiple parents at the same time. I guess maybe that's pretty obvious. And so my question was kind of like, so what is the true benefit of that? And the scenario that I was thinking of is just to keep it really simple. We have say two blocks that we want to refer to both as parent blocks, and let's say we're only able to use single parent Casper, and so we can't refer to both of those as parent blocks. And so I guess what we might want to do is just take whichever one is smaller, let's say, and kind of just use that as the data that we're going to build on top of the block with. So like we had block A and B, and block A had, like less data in it or whatever, and none of the transactions in either of those blocks conflict with one another, then with a single parent Casper, we could just build on the chain that block B is contained in and just add the data from block A on top of that. And, like having seen all of those things, you could validate them and all of that. So I guess, and now you're increasing the height of that particular chain, of course, because now you're building on top of it to get that data put in, instead of just having two parents with mutually containing the data that you want. So yeah, I guess I'm just wondering like what the performance benefits are, like, that sort of stuff.
In a sense, this looks like ordering, right? If you have only one chain, one parent, right?
Yeah.
I mean, you want to decide in which order you want to put it, right?
Right.
And for transactions, which transactions are stored in the block, and
yeah.
I like to think about transactions in terms of some language, right? Transactions can be just the addresses or the amount that you want to transfer, and searching for conflicting means is this the same address? If you're doing the transactions on the same address, which is conflicting, but in more general sense. Maybe this is like variables.
You mean like writing or reading from the same channel?
Yeah. But
okay.
Yeah, this is very general. Like this is in Erlang, but maybe in some lambda language where you are accessing a variable, and then how can you decide if two programs are wants to do some different computation on the same variable. So what to do in sequential language? I mean, you want to have some way of ordering stuff. So in that sense, I see like benefits of multiple parents, because you have language that supports this. Maybe if you have a lambda language, maybe this is not so obvious, or maybe you don't have so much benefits. And then maybe it's much more difficult because you need somehow to include some synchronization, right?
Yeah.
Maybe synchronization is directly related to ordering in this.
Right. Because I mean, there's the whole business with the synchrony constraint as well as synchrony and fairness constraint. But my understanding was that was solely, at least the synchrony constraint was solely about liveness for Casper.
But these are restrictions, right?
They're not what?
Restrictions. You have all the possibility in your language that you want to put in the block, right? And then you want to have some restrictions, because you don't want to allow some things to happen, right?
Yeah.
If you send too many blocks, you want somehow to restrict this.
Yeah. Right. So you're talking about like the rabbiting stuff that's been going on a little while, right?
Yeah, Greg was saying that if you want to have liveness, you need to. So for liveness, you need to restrict propose. So to prevent rabbiting, you need to restrict producer.
Yeah,
Right?
and I think that intuitively makes sense, right? Because like you could have a ton of blocks being produced, and I guess somehow that's a high level of performance if everyone is just disregarding everything that anyone else is saying and building all of their own stuff, right? Because then you don't have to process anything from anyone. You just like do your own thing and just like everyone goes off in their own direction. But like how useful is that in terms of like coming to consensus on anything?
Yeah. In that sense, you pretty much can be live as you want for yourself, but for the whole network, right?
So I guess like general liveness maybe is not the most important property for like a blockchain to have. I guess it's really like effective liveness or some useful liveness. I'm not really sure how to say it, but you have to have some kind of notion of like we're actually coming to agreement on things that matter instead of just like no one cares what anyone else is saying and we're all just building our own little universe.
Yeah, and the fairness is the other side, right?
I loosely understand it as the synchrony is about consumes and fairness is about produces, but I'm not really sure I understand it much more than what I just said.
So Sebastian implemented simple synchrony constraint and a simple fairness constraint where he introduced queues for each validator, for messages from each validator, and simple algorithm that you will take messages from each validator in a fair amount, and there is some threshold where you can say, oh, I didn't hear from this validator, but I waited long enough, so I will continue with the other validators and just keep working.
Okay, so that's fairness, right?
Yeah.
Okay. Just so I understand, so we're saying that this fairness stuff is basically like, okay, now every validator has some queue that's filled up with messages that like as they receive them, let's say that determines order or something. And so instead of just like naively processing from like, the longest message I've been holding on to until the most recent one, it's like actually scanning over that queue of messages and saying like, oh, like I see 50,000 messages from this one node and like, maybe a couple from these other. And so I'm actually going to like pick one from that one that I have 50,000 from and one from all of these other guys just to like make it fair or whatever.
Yeah.
Okay.
And this is exactly the core of logic T, which defines this interleaving operation. So you can talk about different queues, as you said.
What do you mean by different queues?
From different validators, you can. You have this input stream that you're receiving, but you can stop and inspect and say, oh, I will not process this message from this validator because I have it already too much, and I will start with the other.
So, I mean, like I understand that somehow logic T is being used there, and like I don't fully understand logic T, so I'm not gonna pretend like I do. And like I understand intuitively at least what you just said, how Logic T kind of gives us that capability. But I guess in my mind, like, isn't it as simple as keeping some kind of like counter of like, okay, I've used, you know, this many messages from this one, bin, like I only want to use so many, like less than 5, you know, whatever the number is. Or maybe it's like size of data that you use from them, you know, something along those lines, but you can kind of like keep track of that. And then, you know, once you're at that threshold, you're just like, well, don't accept any more, you know, don't accept any more messages, but don't process any more from the queue, and like only look for other messages. And if you don't have any, well, then like you just kind of wait, I guess.
Yeah. Yeah, I mean, you are completely right, and I see Logic T as a generalization. Where you can you have very simple semantics, and you can express this kind of stuff. I see what Sebastian did and what you now subscribe is you can do the same thing for parsing something, right?
Yeah.
So if you have if you want to parse ABC and you have you know so you have 3 streams and you are parsing ABC, and in one stream you have infinite A's. Without Logic T, you will just stuck on the first one, and you will never look the other. And that's the problem, because you have other stuff on 2 other streams, but you don't have a way to you know take a look. And you know and with Logic T you can do this in a sense that you interleave all of the 3 streams, and then you can easily, you know, choose ABC, 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 ABC.
Okay, I have a question, and maybe it's totally silly, but so does each of the N validators in the network have a queue that's associated with all of the other N-1 validators?
Yes.
So like, oh, they do. Okay, great. So
yes.
So like if there's 3 validators in the network, just to keep it really simple, then each one of those validators has 2 queues for each of the other validators to kind of keep track of like how many messages or what messages they're getting from each of those respective validators.
Yeah.
Oh, okay. And then Logic T is just enabling, it's just some kind of tool that's allowing us to fairly interleave those messages from the different queues. Okay, that actually makes a lot more sense.
I mean, Logic T is not used in current implementation. It is this queues, and you know, I see it like a more manual, because you're working with the queues directly, and you know.
Okay.
That's something that is more general, and then you just describe some your mini language with these properties. And this is something that I'm thinking, you know, when you will progress with your TLA implementation of Casper, maybe we can think about, you know, how can we translate this and use something like Logic T to, you know, to do the same thing, because this is, you know, like these are the building blocks that can help us, right, to do this.
Yeah. So is that the plan for the future, is to actually use Logic T to do that reasoning and like fair interleaving, or is Logic T just kind of being taken as a template of like, this is basically what we're going for, but we're just like writing our own implementation of it?
Well, maybe it's more complicated to write it, or in the current implementation, it's like more ad hoc. So what Greg was explaining with Logic T is more general, and we can implement liveness and fairness, you know, with more attributes, and you know, we can have more knobs to tweak. And
okay.
And maybe we can implement the whole Casper in this way, when we can, you know, use fairness and liveness maybe in more general way.
Mm-hmm.
I'm not sure how to do this. You know.
So one thing Rao has been asking me, and I'm not sure about the answer to it, is how the synchrony, or maybe this is just a question that I've formulated in my mind based on discussions that I've had with him. So how does the fairness constraint compare to like a leader-based type of consensus? So like what I'm thinking is, so Casper Labs, you know, published their what they called a specification. Now they didn't clarify what kind of specification they were talking about. I mean, their paper is like, you know, 20 or 30 pages long or something, and it's, you know, it's technical obviously, and you know, so I haven't read through the entire thing, like, you know, just to be very transparent about that.
But you read this Medium article, right?
Yeah, I read the Medium article. Like, I think I have an intuitive idea, which I don't remember off the top of my head right now. But if we started talking about it, I think I'd probably remember. But either way, so they say that it's a leader-based. So I guess so it's a leader-based implementation of Casper, and so like my understanding of that is there are different rounds, and like I don't know how many blocks are produced per round or epic, or, you know, I guess people call them different things. I know Ethereum calls them epics. I know our chain calls them epics, and I think that's what they mean. It's just like some.
Well, but
yeah.
I'm not sure that you know, we don't have rounds. We don't have notion of rounds in our implementation, Casper. I mean, these epochs are some amount of blocks, right? But they're not related to Casper, like to consensus directly.
Oh, okay. So rounds are typically about what, like some sort of finalization or something like that?
Yeah, I'm not sure where used. I mean, I know only one place when you rotating validators, you want to have some kind of number of blocks that you know.
Yeah, and that's kind of what the epics are used for, right? Is for validator rotation and that sort of thing.
Yeah.
Okay.
Yeah. But in. Mm-hmm.
Yeah, I was just gonna say, and so like I was saying before, like I don't fully understand all of the nuances that Casper Labs is using in their highway protocol stuff.
Yeah.
But what I got from it was that there's some notion of an epic or a round, you know, whatever word you want to use for it. I'm kind of using them synonymously in my mind. And during each one of these rounds or epics, there's like some pseudo randomly determined leader for the round, and like I don't really understand what the purpose of the leader is. I think the leader is supposed to be like the one that's issuing blocks in that particular time frame, and by time frame I mean like, you know, round or epic, and that's going to be determined by a certain number of blocks or something like that. So, you know, let's just say it's 5 blocks or something, and so like every 5 blocks that's created, it's always just created by one particular validator. And then, you know, after they create the 5 blocks, pseudo randomly, another validator is chosen that then creates 5 more blocks, and then that process is repeated. That's kind of my intuitive understanding of what's going on, but like I said, I don't know for sure.
I was thinking that after each block, but you're saying that this number can be right.
Oh yeah, yeah, maybe it's after each block, but you know, just as an example, I said 5. Yeah.
Yeah, this is my understanding also.
Okay.
And then you know what is my question? And I cannot relate this directly to the paper because my understanding is more from the Medium article like these highways of you know. Okay,
Yeah.
the rounds, the fixed round is the problem, right? This is
Yeah.
similar to the other protocols, right? Like Ouroboros from right, IOHK.
Yeah.
So,
Yeah.
and this is the problem, right? Because you are waiting for something to happen, and so in the Casper paper, they say now we have multiple in the article. Now we have multiple highways to express the different length of these rounds.
Yeah.
So my question is, how can you solve problems just by adding another fixed length of this round? You know, you just adding, but you still have fixed numbers. You know, and they described they describe another action like hop, right? You're hopping from one highway to another, right?
Right. Yeah, and I don't remember specifically what determined those hops. I remember there being like some multipliers by 2, but I don't remember what that was
yeah.
about.
So my question is, are you just translating the problem to you know to another corner, right? Because
Right.
now the question is, how are you managing these hops? I mean,
Right.
now you have different lengths, different
My,
rounds. You can have as many as you want.
my
Yeah.
understanding,
Yes.
I guess, it was in the grandpa or whatever it was. I
Yeah,
mean,
they have similar.
you know, the basic idea of a round is say, okay, a certain number of stuff has happened. Now we're going to force a decision, and this gives
Yeah.
us liveness by forcing a decision after a certain amount of activity measured by some mechanism that determines the length of a round or whatever. In our chain, um, Greg was using the spatial um,
The space-time calculus.
the space-time calculus to determine you know to limit uh, how deep somebody would go into the process so that you would get finality. Okay, and that's sort of the round. The equivalent of the round is the space that is the size of the space that you're examining.
Okay. Okay. So
Jim, are you saying that? Yeah.
Oh yeah, go ahead. Go ahead, Tom.
Jim, are you saying that we have some kind of rounds in our chain? Because I was thinking that we don't have notion of rounds directly, right? They're emerging. You can go into the history and say, oh, this looks like a round, this looks like a round, but right.
I don't think anything was implemented. I mean, Greg just presented the the space-time analysis of you know where you can you can end a contest by exhausting as far as you need to look and not go on forever without reaching consensus, which is not the same as a round, but it's another mechanism of obtaining finality. In grandpa, okay, you know, a certain number of, you know, when a certain number, you know, what was it, when 2/3 of the nodes had seen something, it became it became one thing, and then by the time the grandfather became well known, you would finalize it. So, you know, by how many people had seen it, determine whether something was well known or I can't remember all the technology, but the idea of a round was actually going through the process of blocks becoming well known. And I don't understand the Casper Labs thing. What I thought I understood was that they would that it was almost like that they did a kind of voting thing. When when something became well known, so to speak, what was the vote? And then that was how the leader was selected. But I didn't even read the Medium article, so don't quote me.
I mean, the leader will create blocks, right? That's the point.
That I believe so. Or I mean, unless you're saying definitively yes, that's the case. But that's my understanding.
Yeah. Okay. We would all would choose a leader, not necessarily the same leader, but if we follow the chances are that if we follow a leader, we're going to choose the same one, and the same block is going to be finalized.
Well, my understanding is that we will choose the same leader, right? In a sense, this is also like a problem.
On, where the communication breaks are or whatever. But if everybody's honest, we'll all choose the same leader, right?
Yeah, I mean, if you choose some other leader, you're not following the protocol, right? We can discard the messages from this validator. Yeah, and you mentioned the rounds. Yeah, in Arch and Casper, we don't have rounds as a time, like a wall clock time, right? But we have rounds in the terms of these synchrony constraints. They will reduce the number of messages that you are allowed to send and to receive.
Yeah, I think it's getting at the same in a slightly different way.
Yeah.
Yeah.
I was
just gonna say I put the Casper Labs highway protocol paper in the consensus Discord. Just so you guys have it too. Yeah, like I said, it's pretty technical though. I don't think we're going to be able to look at it now and really be like, oh yeah, I thought that's exactly what it was, So.
Yeah.
What were you going to say about Greg now?
Well, Greg was saying that with wall clock time, you're doing the same thing, but keeping the wall clock time is problematic. That's the problem.
Yeah, which is interesting because, I was just briefly reading, I jumped to the third chapter of this paper about liveness, and the first section is called Leaders and Ticks. And the first sentence is, we measure time in milliseconds since the epoch, which is interesting. So they're somehow keeping track of some notion of time. And I don't know what exactly that means. Like every node is keeping track of a notion of their, local time, or there's some global time imposed. Like I really don't know.
Yeah. Yeah, and how you synchronize and. Mm-hmm. I'm not sure if you need to explain this if you write this kind of paper. Can you just say, oh, we have this time, we are measured time, we know what time is, and you can use it in your proofs and say, okay, I proved. So,
well, I guess when you're not even explaining what kind of specification it is that you claim to have, then sure, why not?
And the question also that I have is it enough to have partially synchronous proof of consensus
for liveness?
I mean for performant network and for something like Arch.
So what do you mean by partially synchronous?
Well, this guy from Hashgraph, he was explaining that we cannot prove completely asynchronous communication.
Yeah, right.
So we have proof that this is not provable, but we can have I think that we can prove partially asynchronous communication.
Yeah.
So I'm not sure if this is something that Greg wants to achieve, you know.
Okay.
Because this is like much more much, you know, much more capable of consensus than the partially synchronous. So,
Yeah.
and can you build partially asynchronous consensus with a leader based system?
Right. So I guess in my mind though, like asynchronous is a very well defined thing, and so like asynchronous, you know, in terms of like a process calculus or something like that, like asynchronous pi calculus, right? It's like there's no continuation for a send process, basically, right? So you have no direct guarantee that your send was received, right? But you do have this notion of acknowledgement, and so is asynchronous pi calculus really asynchronous, or is that partially synchronous?
Well, I was thinking that asynchronous doesn't have any acknowledgement. So are you saying that? Are you saying that in asynchronous pi calculus you have some kind of acknowledgement?
Yeah, I mean, why wouldn't you be able to? Because you could just, you know, receive the message, and anytime you receive a message, just also in parallel send an acknowledgement back to the, you know, back on that channel, saying like,
yeah, but
I got this message.
But I mean, but you are doing another communication. I mean,
Yeah,
it's not.
Yeah, definitely, right. Well, and so I guess then the issue is like, even if you send an acknowledgement back to the channel that sent you some data, how do you know that your message was received? And so they would have to send you back an acknowledgement, right? And then it's just like forever back and forth, like, hey, I got your message. Hey, I got your message. Hey, I got your message. Message.
Yeah, but we have a TCP that works, right? and it's doing the same thing, right?
Yeah. Wait. So how do you bring TCP into this? Like, what does that do for us?
I connecting this directly to error correcting codes, because in error correcting codes you are using multiple interactions. You are sending multiple messages to somehow to somehow create this synchronic constraint, right? If you receive 3 zeros, you can say, oh, I will think this as, you know, confirmation that, you know, this is 0. So I think this is where you can with multiple messages you can somehow conclude that you know you transmitted some information. You have this error correction. So in a sense this is something interesting happening here, right?
Yeah.
You're just using the same thing multiple times, and you can, you know, prove something or be sure of something.
But the sender still never has the guarantee that the receiver is getting those messages and doing anything with them, right? I mean, that's kind of the whole point of the synchronous asynchronous stuff.
But you can do, if we are agree with this encoding, right? Three zeros and three ones for 0 1. We can encode what, you know, what when you do something you will send another 3 zeros and ones, right?
Okay. Yeah.
I mean, if you have send and then in par something, as you said, this is like encoding of this confirmation, right? Without having direct acknowledgement of each message, right?
Oh, I think I see what you're saying. Okay. Yeah, that kind of makes sense. So, but you can do that in asynchronous calculus, right? I mean, like that's the whole point, is that we can do that in Rolang, which is based off of, you know, like the row calculus, which is asynchronous, right?
Yeah.
But it's almost like in an asynchronous calculus, it's almost like with that idea kind of put on top of it, you already have some sort of notion of synchrony.
When you're sending acknowledgement and then, right?
Or doing this error correction thing where you're sending, like, you know, however many you determine, like, this is the right number, like I need to see, you know, 20 messages or something to know that you're, you know, the majority of them have to be the same exact thing for me to know that, like, that's really what you're sending to
me. Yeah. And then in distributed settings, right, you can inspect all of the justifications that you received from other validators, and you can confirm, oh, not only that I see one number of messages, or one, I can count the number of validators are seeing something. I can really conclude more. I can see, you know, in which order they are processed and received by others, right?
Yeah, because of the justifications you said.
Yeah.
Okay, yeah, but that, I guess that's even another layer on top of just like the kind of underlying calculus that's being used.
Yeah. And if you send a message to a validator, I mean, you have acknowledgement in the sense of TCP and everything, you know, the connection was not broken until the last byte is received from other party, right? You can say, oh, probably other validator received the message. But, but it's still asynchronous, because this validator could die just after receiving the last byte. And you know, it's gone. It's, you know, it's blown up. And
you never really have any guarantee that they received it, right? You just have guarantees that you sent it successfully and it's sitting in their, you know, channel or whatever, waiting for them to receive it.
Yeah, maybe there is some kind of caching on the data center, and it's really not received. It's just, you know, in transmit. And
yeah, right. Yeah,
and some cache.
Somehow the tuple space freezes before your message is, you know, well, like right as your message is being added to it, and you know, it's like it's in there, but you can't actually access it because now it's in some corrupted state or something.
So you definitely need other messages that you receive that you can confirm that, you know.
Yeah, right.
And this like this just intuitively creates some kind of rounds, right? Rounds of communication, rounds of chatting of the same thing.
Yeah, right? You mean by like
all the validators are sending the same thing with different order and justification, just to say, oh, I seen it, yeah, it's here, it's here. Yeah, okay, we are agree, yes.
I mean, yeah, that like all of this stuff kind of reminds me of Hashgraph, but I guess that's because I feel like I understood that notion in Hashgraph the best, and so now it's like, you know, we talk about Grandpa or like, you know, Archain, and you know, it all kind of sounds like we're getting at the same stuff, you know.
Yeah. For me, it's very similar.
Yeah, that's cool. Let's see. Well, I didn't even plan on talking about any of this stuff, but I'm glad we got a whole hour out of it.
Yeah.
What was I gonna say? I was gonna say something. Oh yeah, so we were planning on talking about that matching document that you had found, and then I also wanted to talk about discipline or the PyRChain API, or like PyTest in general. I guess I'm I have watched about 45 minutes of Python introduction. So like that is my level of knowledge of Python so far, but it seems really simple and straightforward. So I don't anticipate a whole lot of like snags with Python, but I don't know, maybe you have more insights.
Oh yeah. Python is pretty simple, and
yeah,
I didn't use Python like maybe last year. I was using it much more, and have some kind of deep dive. And I was expecting more advanced or more complicated language, but it's not. It's super simple, and I think now I can see why a lot of people are love Python, and it's very easy and simple, and
So do you get any sort of like safety guarantees out of Python? Is it like type safe, like that sort of stuff? I mean, I guess I'm not sure what question to ask, but maybe you know what I'm getting at.
There is some typing system that you can use.
Yeah.
You can,
well, I mean, I know when I'm say like print add this string ABC to this integer 5, it'll throw an error and say like, hey, I can't really do that for you,
Yeah, dynamically it's typed. So in runtime you have types, and you cannot mix whatever you like, right?
Yeah.
But you don't have any static information.
It's not statically typed.
Except if you are using types. So there is support for types, but I didn't have I didn't use types, so I'm not sure how well are.
Yeah, I was gonna say, I haven't gotten into that. I've gotten into like in functions on strings, like pretty basic stuff, like picking, so strings are stored in Python as arrays, I'm assuming, or functions maybe is the better way to say it. So like so in PLA plus, most things are interpreted as functions, and by that I mean like bags, like multisets are interpreted as functions, and basically the function that's associated to any given bag, say the bag is like the bag that contains the string A 3 times and the integer 0 twice or something like that. So you have a domain for that. Obviously the domain is the set of 2 values, one being the string A and one being the integer 0. And then the function that you're associating, so like the values that you associate with those elements in the domain is like how many copies there are, right? So like your function would map the string A to 3 and the integer 0 to 2 in my example.
Interesting.
Yeah, and so I thought that was a really cool way to think about multisets. They do the same thing with sequences, and they do the same which are basically tuples, and they do, or lists, I mean, because they're all kind of the same thing anyways. And they do the same thing with records. And with records, they make, so like in a record, obviously you kind of like name each one of the fields, and then you have, values associated with those field names. And so what they do is for a record, it's a function that as its domain has the set of all of the individual field names as strings. And so then with each one of those strings, you're just saying like what the value is associated with it. That's kind of like the output value for that function or whatever.
I see.
And
this like seems intuitive, but
yeah.
For multisets, it's not completely right. I didn't expect like this, or how you see it for a sequence.
Yeah, and so for a sequence, the domain is just like 1 to the length of the sequence, and so then for each position or index, you're saying like what element is sitting there.
I see.
Yeah.
So in a sense, I see it. I see it similar to records or maps, where the index is the name. It's not string.
Yeah.
It's integer, and then the value is
Yeah,
looks
yeah. I mean,
on this position.
map is a function, right? Like mathematical functions.
Yeah.
Yeah.
And then for multiset, you said what is the result of the function? Is the number of
yeah. So for a multiset, the function that represents any given multiset is basically that function that has domain equal to the set of all of the individual elements that are in the multiset, and then for each one of those given elements, you just say how many copies of that element are in the multiset.
I see.
Yeah.
Okay.
I
didn't think about that in this way, so yeah. Okay.
Should I type that? Would that make more sense if I?
No. I completely
okay.
understand, but I didn't
Yeah,
expect that this is represented in this way. You know.
Neither did I. Neither did I. I was like, wow, what's the syntax for a multiset? And then I looked up the module, and it's like, has this predicate that's like, is bag, and you can like give it some thing, and it'll tell you like true or false that it is a multiset. And what it does is it checks to see if it's in the collection of functions that have the same domain as the thing in question, and range in the natural numbers, positive natural numbers.
And for the set, how the set is represented?
Yeah, so sets are also like kind of primitive, I guess. So like sets are primitive, and then from sets you can build functions, and so I'm assuming that's where they get the functions. I'm not 100% sure how all that comes about. I gotta look at something really quickly.
So you're saying the set is not represented as a function,
right?
Set is like a primitive from which, oh, I see.
Yes. I mean, but you could represent a set as a function in a pretty straightforward and intuitive way by what they call the characteristic function, which is basically like if the element is in the set, then you assign it the value 1. If the element is not in the set, then you assign it the value 0. So I mean, all of your functions have infinite domains then, but it's not really that big of a deal, I guess.
Yeah, it's like a predicate, right? You're just saying, is it in the set or not? And
yeah, exactly.
This in a sense look like a type, right? You're
yeah. I was looking. I put something when I was talking a lot about TLA plus. There was dang it, I don't remember where this was. Some kind of set programming. Oh man, this is really close to where set L is what it was called. I guess it's called set language.
Oh, you put link.
Yeah, just like to the Wikipedia article, I guess.
That was very interesting.
Yeah, my understanding is that the sets in TLA plus are kind of either modeled from that or built off of set L. Yeah. So the sets are like kind of the primitive things in TLA plus, and that's one thing that Leslie Lamport is always saying is like everything is basically interpreted as a set until you say that it's different than a set, essentially.
Yeah, I mean in Agda they have set as the first type. I think that now they have a type as a primitive, but they started with a set.
Okay. Yeah.
And in lots of the code you see set as everything is built from set.
Yeah. You said that's Agda. Yeah. Okay.
Yeah,
I don't have any experience with Agda. But...
I was listening to some lectures, and it's when you listen about the features, and everything looks pretty logical and understandable, but to write in the code is so I'm waiting for Greg to write some of this stuff in Agda. He was saying.
Yeah, he was saying that he was gonna type up some of the proof theory stuff. Was that in Agda that he was talking about doing that?
Yeah.
Okay. Yeah. Cool.
So Idris is very similar, and
yeah,
I was thinking, maybe I can look at his code and just, much
try to do it.
Copy something and yeah. It shouldn't be too hard, right? It should be much easier than just do this from the paper.
Yeah. Do you know much about lean?
I'm not sure what this is.
So lean is like I'm definitely gonna say this wrong, but I'll find a link or something and put it in Discord. So lean is from my understanding, some kind of programming language that allows you to do like formal mathematical proofs. So you can, define things, say like, a circle is like, say circle radius 1 center at the origin, basically it's just like the collection of all of like the tuples like x, y, such that, the equation x squared plus y squared equals 1 is satisfied, for example. And then you can, so you can define kind of like mathematical objects in it in a very abstract way, and then actually do proofs of, theorems and things like that, and have it, automatically check that like your proofs are actually good, I guess, or correct, maybe is the right way to say it. And I've seen this guy from, I want to say he's from Cambridge. It's probably not right. All of the schools kind of, I don't know. Though I don't really care what school you're from, or not even from a school, it's fine. So either way, he's British or something along those lines. And so he was talking about this lean stuff, and basically suggesting that like the state of mathematics is such that proofs are too complicated, and basically, verification of proofs is kind of left to like a very small set of people who like really understand things. And not that that's necessarily a bad thing, but the issue that comes up there is that when you understand things really well, sometimes you aren't as careful, and you kind of like take things for granted a little bit because you're so familiar with the assumptions that are used and that sort of stuff. And so his argument was kind of like, we need to be formally verifying like all of these mathematical proofs, and like lean is a tool that can allow for something like that to happen, essentially. So I didn't look into it a whole lot, but that was my takeaway from all that.
Yeah, this makes sense. I mean, how general this tool is? Like, can you prove like mathematics or some foundations, or?
I don't know, and I don't know how it's built. Like, I don't know what language is used to build it. I think like, if this isn't right, like, don't quote me on this, but I think it's the EPFL guys that are building lean. They're the same people that do the stainless stuff. They had another thing called Insane. I don't remember what the Insane tool was about. But this is like, I think where, now again, don't quote me on this, but I think this is where Martin Oderski is from. So a lot of Scala tools are coming out of the TPFL. But I think they're responsible for lean, and I can double check that.
I see. Yeah, this sounds interesting. I mean, this Vladimir Vygotsky, he was, he was doing like stuff about proving mathematics and mathematical foundation. And do you know his story? How he made some proof, and get the medal, and and few years later, he found out that he has a bug, and you know the problem is in his proof.
Oh, really?
And you know, and his paper was reviewed and everything, you know. And
Right.
he was totally
Right.
disappointed of the whole thing, you know. We are doing like mathematical stuff, super complicated, but you know, maybe it's just wrong, you know. It's
Yeah.
so
Right.
so he stopped working on what he was working, you know, and just you know. Just starting to think about how to prove all of this stuff, how to use computers for how mathematicians could use you know, computers
Yeah.
to write proofs.
Yeah. Interesting.
So yeah, I'm wondering, you know, is this in the same direction of his work? And he was talking about. I don't know, you know, exactly, but he was talking about groupoids and infinite groupoids, and this relates to this type notion of type, which is like, you know, spiral, and you know you have in type theory you have type and type of type, and all of these types are represented as a type, but
Yeah.
in the background you think of this as a infinite tower of types.
Yeah.
So I'm wondering how they represent. I mean, the first problem is how to make proofs as mathematical objects, right?
Mm-hmm. Right. Yeah. I mean, I don't know how the representation works. I know, well, I remember them saying, and maybe not even correctly, that the way that the proving works in Lean is like somehow it generates some list of tasks that it has to perform, and then it's like in performing each one of those tasks, it proves the theorem or what it is that you want it to prove, like based on axioms or definitions or whatever. It always goes back to first principles, right? It's like it only so it knows all the operations of mathematics, but like in terms of definitions and things like in axioms, it only knows what you tell it.
Can you compare this to what Greg is saying about these two notions? I remember when you were talking with Greg, he was mentioning this. He was explaining his paper, and he was saying we have the two notions like model checking and this other way of checking. Can you say something about that? I'm not sure.
Yeah, I'm trying to remember.
In TLA is like model checking, right? And Greg is saying, yeah, this is like good stuff and everything, but he was also adding something, why is model checking is not the answer, we need something else, and I'm not sure that I understand.
I don't remember if that was what led into the discussion about the proof theory stuff. Like, I don't know if that's the other side of the coin or whatever.
Yeah.
But so I mean, TLA Plus has both of those tools. Like, there's a theorem prover aspect of it, which I have not worked with yet, and there's also the model checker aspect of it, and that's so there's like TLA Plus, which you write your specifications in, which are basically just like mathematical definitions or whatever. And then with the model checker, you can kind of do, like assigning values to different variables, and then kind of seeing how things work out given that those values initially are assigned to those variables, and just going through kind of like brute force, just like checking all of the different possible states. And you can put constraints and things like that on it. but that's essentially the idea. And but they also have like a theorem prover. So, you know, it's like in model checking, you're not going to get a guarantee that something is correct. But with a proof, you have a guarantee that something is correct, right? So like you can prove, for example, I guess in the way that Colab has you know, attempted or successfully done, like I'm not sure what the right way is to say it, with their like proving liveness of their highway protocol, right? So in my mind, when you say you've proved some property, you know, it's like you've written some rigorous mathematical definitions, which it looks like they have done, and then done a rigorous mathematical proof of this claim that you're making. But I guess to me, it's a little bit strange. So I was expecting to see like a TLA plus specification or something, and that's not what was there. And I guess I don't know why, because you could essentially just translate all that stuff to TLA plus. So it's like, why not do that? But I mean, I don't know what their intentions are exactly.
And so, is this a theorem prover part of this tool for TLA, or?
Yeah. So yeah, there's it's called TLAPS. So it's like TLA plus TLA proof system, I think is what they call it.
I see. Cool.
I don't know why I can't find this. Okay, so it's definitely this. Here we go. Okay, getting closer. Insane. I know that's one. Okay, great. How about just here? So now, can I finally? No. Could have sworn this was associated with these guys. Yeah. Oh, yeah. So the other thing that EPFL, I guess it's EPFL -Lara, and it's like the something automatic reasoning, laboratory for automatic reasoning, something along those lines. I don't remember what the acronym is for, like LARA. But yeah, I mean, they have the stainless stuff. Oh yeah, they have the system FR, like formalized foundations for stainless. Oh, here, I can share this, I guess.
I was thinking that stainless doesn't support higher-kinded types.
Yeah, right.
I was thinking that I know how to translate higher-kinded types to just regular generics, just, you know, regular polymorphic types.
Oh, okay. Yeah.
So maybe we can do something like this, right? To if we can, you know, mechanically transfer or generate like normal polymorphic types from this higher-kinded types, maybe we can use stainless.
Yeah, I think that would be great, because stainless seems like a really good tool. Yeah, I mean, that would be awesome. I would love to talk about that more. They also have this Inox, this Scholar.
And I remember that I was reading for stainless. They're not doing the proof stuff, right? They're just generating for this Z3 library or some.
Yeah, yeah.
I would like to know what is exactly this layer of stainless
here we go.
Represents. Oh, lean. Oh, yeah. I was reading about that. Now I remember.
Yeah, for a second there, I thought I got lean confused with Leon, you know, because it's Leon, but apparently they have both. So yeah, this is it.
So
yeah, so these guys
they
are
created this. Oh, okay.
I could have sworn I had.
Why they are using Z3 not lean for stainless?
Yeah, I really don't know. I mean, I think Z3 is probably just like so much more well developed at this point. That would be my guess. I mean, it looks like how
And
old
in
is
which
it?
language is this? Can you take a look on
Oh,
GitHub?
yeah, sure. Where should I look for something like that?
If you
Source
click on
code.
this on this line, no, you
Which
must
one?
go to the root, and you must go to the root on the top. You click on this line, a thin line in red.
Oh,
Or
this
yes,
C++.
yeah, C++. It's the same as Z3 is also C++, I think.
That I don't know. So Microsoft is responsible for Z3, right?
Yeah, I think it is. Yeah.
Yeah. Let's see if I can just find Z3. Yeah, it looks like C++. Investment. Oops. Ah, I didn't even know you could click on this. That's pretty cool. Yeah, C++. Yeah, it doesn't
I mean,
look like.
the stainless and this kind of stuff are completely general, but
Right.
maybe we can use only part of it and just generate for specific for us, and maybe maybe we can in that sense use it more.
Yeah. Well, okay. Looks like there's tons of information about lean. I don't know why I was having trouble finding all of this stuff, but maybe it's because I wasn't searching lean prover. Either way, where do I? Oh yeah, that's right. I stop here. Okay.
Maybe we can stop recording and switch to this Python stuff.
Yeah, I think that's a good idea.
Yeah.
I'm gonna take a break for 1 second. I'll be back in just 1 second though.
Okay, Jim. Okay. I don't hear you.
I think Jim stepped away. I can stop the recording, I think.
Oh, let's try.
I've got to have my glasses. I can't see anything.
Maybe. Oh, Jim, you're here. You can stop recording.
You what?
You can stop recording.
Okay.